Hello, how are you? I'm back again. If you're new in my channel, welcome. I welcome you. Please subscribe, like, and share so that you can join Ponto Resource Tutorship and learn. So now, question 5, May, June 2023, Physical Science, Paper 1, Work Energy and Power. Now, question 5. It says, an electric motor pulls a 20 kg crate from rest. You see? Rest. So my VI date is what? 0 meters per second. It's very important to write everything that you are told in the statement. Apply it on your diagram. And then up a inclined plane by means of a light inextensible rope. So now you know that this one is what? The tension. The inclined plane makes an angle of this 18 with the horizontal. B, C, D are points on the inclined plane, and the distance between A and C, it is what? 15.6 meters, as shown in the diagram. So I have my diagram there. So the motor exerts a constant force of 96, and parallel to the inclined plane. This motor, a constant force. So it basically means with this motor, it is pulling this 20 kg by what? By 96.8, because there is a rope in between. So it exerts a force of 96.8 in this 20 kg block. And then a constant frictional force of 13.5 acts on the crate as it moves up the incline. So it means it opposes motion, it's gonna go that side. So now check 5.1. Define a non-conservative force. Guys, I need to know the examples of non-conservative forces. Those ones like frictional force. So these are the forces that depend on the path taken. So since they depend on the path taken, when this 20 kg is going, it is going there, the frictional force opposes motion, so it will go face where? To the left or downwards. So now 5.2. Use energy principles to calculate the speed of the crate when it reaches point C here. Okay, so now check how I'm gonna do it. So now check this one now. I have what? 5.1, I'm done. 5.2 now. So now I would advise you to always use this one. So now W net is equals delta EK, enormous. Whereby my delta EK is the change in the final and initial. So I'm just gonna simplify it. Half M VF squared minus VI squared. I need to know what this one stands for. Half M, and then what in half MV F squared minus half MVI squared. So I simply factored out half M, and then I'm left with that one. So now let me substitute there. My mass, so it's gonna be what? 1 over 2 20. What is my VF? It is what? It is the one they want, dang it. VS squared minus VI. I told you Lana with what? My VI is what? 0 meters per second, because you're also taught in the statement. So now what is my VI there? It is 0. So half times 20 it is 10. 10 times VF it is what? 10 VF squared, because that one times 0 it is what? 0. So now since I have W net, I'm simply gonna say W net, it is equals to the force that are acting on the object. So now let's go back to our object now. So now check. You know what Lana have what? The normal force, right? And then now, since it is work energy and power, you are advised to use this one. So now, you know this one is the what? The force applied, which is going that way, right? So now, you will have your frictional force going that side. And at the same time, you'll have your what? Your FG parallel, because it is always there. It is the component of weight. So this one is going to go that side. This is the what? FG perpendicular. You see? So now I'm going to take what? 1, 2, and 3. Those 3 forces. So W net, it is equals to what? The work done by friction, because you said W net, the net forces done by the work. So the WF, work done by friction, plus what? The work done by gravity plus the work done by force applied, which is that one that they told us about. So now, under the work done by friction, remember Lana, we have what? 10 VF squared, which you just calculated, right? So under work done by friction, we are simply gonna write what? F frictional force delta X cos theta plus, now you have what? FG parallel, which is the same as what? Mg sine theta. And then what? Delta x cos theta plus what? F applied delta x cos theta. So now, let me use a different marker now. So now check what is going to happen now. So under frictional force, I'm going to include my what? My 13,5. I was told to it is 13,5. What is my distance there? It is what? 15,6. Cos 180. Remember, frictional force, it opposes the motion. So you also saw in the free body diagram that it is going that side. Then this one now, it is what? Cos 0, because it is going with the same direction as the what? As the motion of the situation of the thing there. And then plus what? Now I have what? Mg sine theta, which is going to be the same as what? 29,8 sine 18, ne? Times what? 15,6 cos 180 again, because your FG parallel is acting in the very same direction as what? Is a frictional force. You see, it's very tricky now. Now let's go. I'm left with plus force applied, so it's gonna be plus what? 96,8 times 15,6 times cos 0. Because now check, this 96,8, it is going in the very same direction as the motion, so it's going to be cos 0 there. So now I'm going to put everything in my calculator, and you can also do that just to save time. So what am I going to get there? I'm going to get 354,63, right? So then I've got my 10 VF squared, 10 VF squared, 10 VF squared. See, that is how my things are. Okay, now let's continue. Since it is here, I'm going to divide process by 10, so that my VF squared is equal to what? Take out my calculator there. 354,63 divided by 10 is what? 35,463. So I've got 35,463. Then my square root of 35,463 is what? 5,96 meters per second, as you can see here. You see? So now I'm done. My VF, it is 5 minus 5,96 meters per second when it reaches point C. Now let's go to 5.4. Now check my thing here. It is saying what? When the crate reaches point C, the rope breaks. The crate continues moving up the inclined plane and comes to a stop at point D. Now it comes to a stop where? At point D. And you know, after it comes to a stop here at point D, it do what? Go back there, because the rope has been, it has broken down. So, and slides down to the plane past point B. So now 5.3 says draw a label free body diagram for the crate as it slides down the plane past at point B. So now check how it's gonna be now. Now you know you have your what you call the given statement and situation, right? So now check. It's gonna be what? 5.4. Now I'll have my what? Let me just put my what? My normal force there, right? And then manje, what is gonna be my second force now? What is gonna be my second force? So now let me simply put my what? My FG there, or you can choose that the other one now. So the other one, you're simply gonna put what? This is the direction of the what? Of the motion, because it is now doing what? Sliding down the plane. So let me label. I said this one is my what? FG parallel. And then like let me put the last one. It can be what? That force applied that I was saying about. So this is how it can. So this is 1, 2, 3 marks, right? So or I can put it like this: FG parallel, FG perpendicular, and what? The F, and then what? Fn. So this one and this one have 1 mark, you see. And then 5.5, draw a velocity time graph for the entire motion of the crate, starting from point A until it passes point B again on its motion down the incline. So now they are saying velocity time graph. So it means I'll have my thing here like this. And then this is my velocity meters per second, measured in meters per second. And then lana I have what? My time, measured in seconds. So lana I have what? 0. But now they are saying for the entire motion of crate starting from point A. I need to know that point A, it is now doing what? Increasing, right? And then it passes point B and passes point C. But after C, it continued to go there to what? To point D. But when it reaches, they did what? It went back down. So it lost, it now went back to the original thing. So it was just easy. It was just easy. Just had to put this thing only, and then you're done. See? So now you need to show me the things there that you have to label. Now it's on your own to show me the time and what that thing. Mara things now fine like this, because just like that. Okay, so thank you guys, I hope you enjoyed. All right.